All right, so we're going to get started with our first lesson. It's going to be chapter P, section 2. This is really section 2a, right? We're going to split this up into a couple different parts, right? This entire chapter P, section 2 is all about exponents and radicals, right? So a lot of this you've seen before, whether it was Algebra 1, geometry, so some of it might be familiar. Some of it might be a little bit new, but for the most part, this should just be a review. And this entire chapter P is for prerequisites, right? So this is all stuff that you've maybe seen before, just in Algebra 2. We're going to maybe make it a little bit more complex. Some of the examples might be a little bit more involved. There might be some vocab that you haven't heard before, but overall the concept should be familiar to you, right? So this entire chapter P is just going to be dedicated to catching you up, right? Because a lot of this you've seen in Algebra 1, which was a while ago. So, just as a refresher, that's what this chapter P is going to be dedicated to. All right, so super simple. I mean, I'm sure you've all have absolutely worked with exponents before. Exponential notation is just a shortcut for repeated multiplication, right? So for example, if you have 2 times 2 times 2 times 2, instead of writing that out 4 times, you're just going to write 2 to the power of 4. Or you can say 2 to the 4th power, right? And in this example, we call 2 the base, and you call 4 the exponent, right? And so you can kind of remember, like, base is the big number, right? So in this, like, quite literally, 2 is the bigger number, even though 4 is bigger than 2, but you see that it's on the page bigger than 4 is, right? 4 is the little number, right? The exponent is this number up top. All right, so x times x times x times x times x, right? Again, you don't have to write it out 5 times. You can just say x to the power of 5. And this is any time the same thing is being multiplied over and over again, right? So even if you have something like 2x, which is an expression involving multiple factors, right? If these are the exact same 2 factors that are being multiplied, then you can write these 2 factors to the power of 4, or however many times it shows up. Same exact thing with negatives, right? If I have a negative y, and I have the same exact negative y that's being multiplied however many times, in this case it's 1, 2, 3, 4, 5, right? It would just be negative y to the power of 5, right? If it's in parentheses, keep it in parentheses, right? You're going to see even later on in this lesson that parentheses can completely change an expression, right? Same thing down here. If it's like a fraction or whatever, no matter what it is, as long as it's being multiplied however many times, right? In this case, 1, 2, 3, 4, 5, 6, 7, right? This is just going to be 1/2, right? That's my factor that's being multiplied, and it's being multiplied by itself 7 times, right? So it's going to be 1/2 to the 7th power. Again, super basic, super easy. This shouldn't be anything groundbreaking that you haven't seen before. All right, so now rules of exponents. You've also seen before, but again, right, even in Algebra 2, like, some people mess it up. So just to give you a refresher, this is the rule for multiplying exponents, right? And the rule is that if you have expressions with the same base, remember, base is the big number, right? So my big number here is a, right? If I have a to the power of m times a to the power of n, then all you have to do is add the exponents, right? You're not going to multiply them. That's for something else. All right, and so examples, if I have x to the power of 3 times x to the power of 4, right? X and x, they match. 3 and 4 are my exponents, so I'm going to do 3 plus 4, and then 3 plus 4 is, of course, 7. If I have a coefficient, right? Coefficient is just a number in front of a variable expression, right? So if I have coefficients, I would just multiply those as normal, right? 2 and 3, these don't have any exponents, right? So I just do 2 times 3, which is going to get you that 6. And then I do whatever variables match, right? And you're going to see in later examples, if you have multiple variables, you're only going to do the ones that match. So if I had an x and a y, I can't do an x with a y. I have to do just x with x, right? So again, these are just being multiplied. So x to the 4th times x to the 2nd right? And then I would add the exponents, right? That's my rule, that if I'm multiplying with the same base, I add. So 6x to the power of 6 is your answer for that one. All right, so now we start some examples. You're going to see in a lot of these notes that I do with you guys, I try to include plenty of examples, plenty of different examples, just so that you know how to handle each and every case. But across all of the examples, the rules don't change. They're exactly the same, right? So no matter what we give you, as long as it follows the same concept, then you should be able to do it. All right, but we're going to start pretty simple, right? So we're going to start with y to the power of 6 times y to the power of 3, right? Now, my base here, big number, is y, right? So if I have a y to the 6th, and it's being multiplied with a y to the 3rd, right? All I have to do, this is going to be y to the 6 plus 3, which is y to the 9th. You don't have to write that little step that I wrote in between, right? Just so that it's apparent I'm writing it for you guys, right? But that's all you have to do for that one. All right. And once again, just like I said before, if you have coefficients, right, I would do the coefficient with the coefficient. So the number with the number, -4 times 3, and that's going to get you -12. And then I would do the variable with the variable, right? So x with the x. All right, and x to the 4th and x to the 2nd. Again, if you're multiplying with the same base, you add the exponents. So 4 plus 2 is going to be x to the power of 6. All right. And even if it gets more complicated, right, the only way that it can get more complicated is if you have more factors or if you have more variables, right? But again, concept is exactly the same. Coefficient with the coefficient, right? -3 and 5 are my coefficients here. You multiply that and you get -15. All right, variable with the variable, so I'm going to do a with the a. If you don't see an exponent, you're always going to assume that it's 1, right? And if you assume that it's 1, you can do the exact same rule that we've been doing before, right? A to the 3rd and a to the 1st, 3 plus 1 is going to be 4, right? A common mistake that I see is people forget that there is an exponent. As long as it's there, then it has an imaginary exponent of 1. You don't have to write it every time, but if you need to so that you don't forget it, do it, right? Because a lot of people would have just said that this multiplies to a to the power of 3 because they don't see an exponent, right? No, this is going to be a to the 4th. All right, and then I can do b with the b. So b with the b is going to get you b to the 6th, right? 2 plus 4. Multiplying with the same base, you add the exponents. All right. All right, same exact thing here, right? I'm going to do variable with the variable, right? I can do m with the m. Again, if you don't see an exponent, assume it's 1. So it's going to be m to the 1st times m to the 3rd. It's going to be m to the 4th. And then I can do n with the n, and that's going to be n to the 2 plus 3 is 5. All right. And if you have more factors, of course, you would just do the exact same thing. All right, so if I had -3 times 2 times 6, right, you can do it one at a time if you need to, but you shouldn't have to, right? So -3 times 2 is going to get you -6, and -6 times +6 is going to get you -36. All right, then you move on to the next one. All right, so x with the x with the x. Again, if you don't see an exponent, it's an imaginary 1. So I get an x to the 2 plus 1 plus 5. 2 plus 1 is 3, plus 5 is 8. So I get -36x to the 8th. And then it's y with the y with the y. Again, if you don't see an exponent, it's a 1. All right, so then it's going to be y to the 3rd plus 1 plus 2. 3 plus 1 is 4, plus 2 is 6. So I get y to the 6th, and this is my answer here. All right, another case that we didn't quite discuss, but shouldn't be super difficult, is that if you don't see a number in front, you assume that there's an imaginary 1 there, right? So even if I see a negative, assume that that's a -1. All right, so in this case, my coefficient is a -1, a -2, and a 6. -1 times -2 is positive 2, and positive 2 times 6 is positive 12. All right, and then same thing as before, x with the x with the x. If you don't see an exponent, assume it's 1. And so you get x to the 4 plus 1 plus 2 is going to be x to the 7th. All right, just add the exponents. And then you do y with the y. There's only 2 y's here, which is fine. Same rules as always. All right, so if I have a y to the 1st plus 5, it's going to be y to the 6th. All right, so hopefully not too bad. This is another rule. And this is raising a power to another power, right? So in algebraic terms, right, this is what we would write. A to the power of m to the power of n is going to be a to the mn, right? And again, if you don't see a sign, just there's a multiplication in between it. All right, so it's a to the m times n, right? And so in words, it's when you raise a power to another power, you multiply the exponents, right? And some examples are as follows, right? X to the power of 3 to the power of 4, right? Power to a power, you multiply, and it's going to be x to the 12th. If I have multiple factors in a single exponent, right? And that only happens when you see parentheses, right? And you're going to see later on that, like I said before, parentheses could change an entire expression. So if I see multiple factors under the parentheses, this is going to go to each factor, right? And again, a factor is just things that are being multiplied, right? So it would be 2 to the power of 2, and then times x to the 4th to the power of 2. And 2 to the power of 2, again, 2 times 2 is just 4. And then x to the 4th to the power of 2, power to a power, you multiply the power, and that's how you get that 8. All right? All right, so let's try some examples. All right, this first one, x to the 2nd to the 3rd. This is a power to another power, so you're going to multiply the powers. It's going to be x to the 2 times 3, which is 6. All right, simple as that. All right, and if your factor, one of your factors is negative, that's fine. Just, you can write it still being distributed to each factor, right? Just your factor is negative. So this is going to be what, negative 4 to the power of 2 times x to the 4th to the power of 2. And then remember, this negative 4 to the power of 2 is going to be negative 4 times negative 4. All right, people mess this up every single year. Negative 4 times negative 4 is positive 16. And then here, a power to a power is going to get you whatever you get when you multiply them, right? So 4 times 2 is 8. All right, super simple. All right, and again, you could have multiple factors. They don't always have to be just a number and a variable, right? Here we have 2 variables. Again, if you don't see an exponent, assume it's a 1. This 2 is going to go to each factor, and this is going to be an a to the 3rd to the power of 2 times a b to the 1st to the power of 2. It's going to go to each factor. And 3 times 2 is 6, so this is going to be a to the 6th. 1 times 2 is 2. This is just going to be a b to the 2. All right, and that's all you have to do there. All right, more factors doesn't really make a difference, right? I have 3 factors here, 3 times m times n. I have 3 things that are being multiplied. This 3 would still go to each one. All right, again, if you don't see an exponent, assume it's a 1. And then so we get 3 to the power of 3. We get m to the 1st to the power of 3 times n to the 1st to the power of 3. All right, and then 3 times 3 times 3, hopefully we can do that in our heads, right? 3 times 3 is 9, and 9 times 3 is 27, all right? And then 1 times 3 is going to get you 3, so we get m to the power of 3. 1 times 3 again is going to get you n to the power of 3. All right? Pretty simple. Same thing for number 11, right? Nothing new there. I have multiple factors. One of them is negative, which is fine. I could just raise that number, negative 3 to the power of 3. And then I have an x squared to the power of 3. All right. Now, negative 3 to the power of 3, remember that this is just negative 3 times -3 times -3. All right, and -3 times -3 is going to get you a +9. And then you still have that last -3, right? This one right here. And so 9 times -3 is going to get you a -27. All right. And now x to the second to the power of 3 is going to get you x to the 2 times 3, which is x to the 6th. All right, next one's the same thing. All right, multiple factors here, just distribute this exponent to each factor. And so this is going to be a 6 to the power of 2 and a y to the 5th to the power of 2. All right, 6 squared is just 6 times 6, which is 36. All right, and then y to the 5th times 2 is going to get you, y to the 5th to the power of 2 is going to get you y to the 10th, right? You multiply those exponents. All right, now when you get to more complicated examples, I would suggest seeing if there is anything inside the parentheses that you can simplify first. If not, do order of operations, right? Do your parentheses, exponent, and then whatever else, right? In this case, you're only going to see multiplication because that's what this lesson's on. All right, so let's look at number 13. Under each parentheses, there's nothing that we can do to simplify. So we move on to the exponents, right? I'm going to work on the exponent that is on the outside of our parentheses, right? So I'll actually use different colors for this one. All right, so this first 3 outside of this parentheses is going to go to each factor inside of this little group right here. So this is going to be a 3 to the power of 3, right? An x squared to the power of 3. And a y, again, if you don't see an exponent, assume it's a 1. Y to the first to the power of 3. And then with this next group, same exact thing. I have 3 factors in here. So this is going to be a 2 to the power of 2. An x to the third to the power of 2. And then again, y to the first to the power of 2. And then let's just simplify everything. I'll start with the blue, 3 to the third power. We've done it a couple times before. 3 times 3 is 9, times 3 is 27. And then I have an x to the 2 to the 3 is going to be an x to the 6. Power to a power, you multiply. Y to the first to the third is going to be y to the 1 times 3, which is y to the third. And then 2 to the second power, right? Let's move on to the red. That's it for the blue. 2 to the power of 2 is just 2 times 2, which is 4. X to the 3 to the second is going to be x to the 3 times 2, which is 6. So x to the 6. And then 1 times 2, y to the 1 times 2 is going to be y to the second. All right, and then this looks like something that we did in previous examples, right? In our first little set of examples. So again, as always, I'm going to do number with the number, right? Coefficient with the coefficient, x with the x, y with the y. All right, so let's start with our coefficients. 27 times 4. If you can't do that off the top of your head, fine, you can write it. All right, I can barely do that off the top of my head. All right, so I do 7 times 4, 28, right? Multiply however you do it best. All right, and that's going to get you 108 as my final coefficient. All right, so it's going to be 108. And then x to the 6 times x to the 6. Again, when you're multiplying with the same base, you add the exponent, so it's going to be x to the 12th. All right, and then it's going to be y to the third, y to the second. Again, multiplying with the same base, you add the exponent, so it's going to be y to the 5th. And that's as hard as some of these examples get. I mean, they'll be different on a case-by-case basis, but the concepts are exactly the same. Right? You should know when to multiply the exponents, when you can't multiply them, when you can add them, when you cannot add them. Right? And then you should know how to handle the coefficients always. All right, so let's do the same thing with the next example. Let's do first the exponents, right? On the outside, I have a 4 over this one. I would distribute that to each factor on the inside, so this is going to be 2 to the 4th times x squared to the 4th times y to the 3rd to the 4th. All right, our next one, if you see a negative but no coefficient, you can treat that like a -1, right? That's perfectly fine to make it easier. And then you would just distribute that outer exponent to each factor, that 2. And so this is going to be -1 to the power of 2. Again, if you don't see an exponent, you can assume it's 1, x to the 1st to the power of 2, and then y to the 2nd to the power of 2. All right? And then you can go ahead and simplify each of these individually. So 2 to the 4th is going to be 2 times 2 times 2 times 2. All right, and if you do that, it's going to get you 16. All right, you can verify that if you want. It's just 2 times 2 times 2 times 2. All right, so 2 times 2 is going to get you 4. This 2 times 2 is also 4. 4 times 4 is 16. Right? And x to the 2nd to the 4th is going to get you x to the 8th, right? Remember, power to a power you multiply. Same thing here. 3 times 4 is going to get you 12, right? It's y to the 3 to the 4. That is a power to a power, so you multiply. All right, and for the purple, -1 squared is the same as -1 times -1, and that is just a positive 1. All right, and so x to the 1 to the 2, 1 times 2, power to a power you multiply is going to be x to the 2nd. Y to the 2nd to the 2nd, 2 times 2, power to a power you multiply. All right, and then now from here, once again, just like before, you can do your coefficient with the coefficient, x with the x, and y with the y. All right, so 16 times 1 is just going to get you 16. X to the 8th times x to the 2nd is going to get you an x to the 10th. And then you have a y to the 12th times y to the 4th. Add the exponents is going to get you y to the 16th. All right, so some of these take a little bit of time, all right, but that's as hard as they get. All right, so if you look at this next one, pretty similar, right? I would do, again, just like always, I would do this outer exponent to each factor. And then this next group doesn't have an outer exponent, so you can leave that alone and just multiply it with whatever you get after you distribute this 2 to each factor. All right, so this would be what, 4 to the power of 2, a to the 1st to the power of 2. Again, you don't see an exponent, put a 1. B to the 1st to the power of 2. And then this next one you can leave alone, right? 5, a to the 3rd, b to the 2nd, right? Nothing really changes with that one. There's no exponent or anything. And then 4 to the 2nd is 16. A to the 1st to the 2nd is a to the 2nd. B to the 1st to the 2nd is also b to the 2nd. With those, you just do power to a power. And then, again, nothing changes with this one. I'm just going to write it out without the parentheses. Right? It doesn't make a difference. And then, like before, you can do coefficient with the coefficient, a with the a, b with the b. All right, so I'm going to do 16 times 5. Again, you don't have a calculator, so you should write it if you're not confident. I believe this is 80. 80, yeah. And then a to the 2nd and a to the 3rd, right? Multiplying with the same base is going to be you add the exponent. So a to the 2 plus 3 is 5. And b to the 2nd times b to the 2nd is going to be b to the 4th. Again, add the exponents. All right, and that's your final answer. All right, same thing for this last one. On this page, you can distribute that exponent to each factor. Distribute that exponent to each factor. If there's a negative, you can treat it as one factor. All right, and so for this first one, it's going to be 3 to the 2nd times a to the 1st to the 2nd. You can write the exponent there if you need. Over time, you might not need to do that, but if at first you're making the mistake of forgetting, then you should. And then this next one's going to be -5 to the 2nd. And then this is going to be a to the 1st to the 2nd. And so let's go ahead and simplify. 3 to the 2nd is 9, 3 times 3. And then a to the 1 times 2 is going to be a to the 2nd. -5 times -5 is positive 25. And then a to the 1 times 2 is going to get you a to the 2nd. All right. And same exact process as always. Coefficient with the coefficient, a with the a. All right, so I can do 9 times 25. Believe that's going to get you 225, but again, you don't have a calculator, so you should verify if you're not confident. All right, 2 times 9 is 18, plus 4 is 225, yeah. So 225. And then a to the second and a to the second, right, multiplying with the same base, you add the exponents. 2 plus 2 is 4. All right, so that's all you have to do. Again, so this entire page was just combining the skills that we're reviewing in this particular lesson, right? So both the power to a power and multiplying with the same base, right? So you're going to need to work with both simultaneously and be comfortable with it. And so this last page, we're just going to do these are examples that you might see some common mistakes on, whether you make the mistake or whether you see someone else do it. Happens all the time. So let's start with 17 and 18. Hopefully you're looking at these and you can observe what the difference between them is. Right? So if you're looking at them, the most obvious difference is the parentheses, right? Number 17 has parentheses, number 18 does not, right? So if it's been a while for you, you maybe do them the exact same way, right? But they're actually going to get you different answers. In number 17, what is being raised to the second power? It's this -4. The entire thing is in parentheses being raised to that power. So this means this is going to be a -4 times -4. Right? And negative times negative is going to get you a positive. So this is a positive 16. All right? But if you look at 18, there are no parentheses. This negative should not be assumed to be raised to the second power as well. The only thing that's being raised to the second power is this 4, not the negative. So your final answer should have a negative just like it did originally because it is not being raised to the second power, just the 4. So this should be interpreted as negative. A lot of people do it as a -1 times 4 to the second power, which is fine. So -1 times 4 times 4, right? And this 4 times 4 is 4 to the second power. And then this -1 was this negative that was hanging out on the outside. All right, and then 4 to the second power, 4 times 4 is 16. Your answer should be -16 for this one and not positive 16. All right, people make the mistake all the time. All right, so if you see parentheses, everything under the parentheses, so this entire thing should be raised to the second power. If it's not in parentheses, just what it's over, not the negative that's in front of it. All right? And then if you look at 19 and 20, they do have the same difference, right? That one has parentheses and the other one doesn't. But if you see what happens to the third power, right? -4 to the third power is -4 times -4 times -4. And we already know -4 and -4 is positive 16. If I do positive 16 times -4, that becomes a positive times a negative, which is going to get you -64. All right, so even though it has parentheses, this is another mistake that a lot of people made, is that they would see parentheses and immediately make their answer positive, right? You need to check and actually work it out if you're not comfortable doing that in your head, whatnot, and verify that you do get the answer that you're supposed to get, in this case, -64, right? And then number 20, same exact issue as this one right here, 18. There is no parentheses, but you're going to see that it's going to give you the same answer as number 19, right? Because again, this is the same as -1 times 4 to the third power. And 4 to the third power is 4 times 4 times 4. 4 times 4 is going to get you 16. Times 4 is going to get you 64. And then you can bring this -1 down. So -1 times 64 is going to get you -64. So same exact answer as number 19, but it's good to understand what the difference is because on a test or a quiz, if you mess up a sign, that's incorrect, right? You should know what cases are going to get you a positive answer, what's going to get you a negative answer, right? As a general rule of thumb, if you see a negative under parentheses and the exponent is an even number, like it is here, you'll get a positive, right? Because negative times negative is always positive. And if it's an odd number and you see a negative as the base, should be a negative, right? Because if you multiply a negative an odd amount of times, then it's going to get you a negative again, right? If that's confusing, write it out, work it out like the way that I did here. There's nothing wrong with that. But yeah, these are just some special cases that you are going to have to be comfortable with. All right, and that's it for the first lesson. The rest of this chapter, P.2, P section 2, is going to be more exponents and radicals, right? So we're going to do more rules in the next video.